And now we are finally here, the final video of Chapter 5. This is video number 2 for section 5.6. We left off at example number 5. We are supposed to given the 0, we need to find the remaining zeros. And what we're going to do is we are going to use synthetic division to make the resulting function a little bit simpler. So we know that negative 3 is a 0. So I'm going to put in negative 3, and I'm going to use synthetic division, put out 1, negative 3, negative 5, and 39. And if we do this right, we better end up with a 0 right here. That's our goal. Drop the 1. 1 times negative 3, and add. Multiply the negative 6 times negative 3 and 18. Add. 13 times negative 3 is negative 39, and add. We get our 0. But more importantly, what happens is we're left with x squared minus 6x plus 13. And then what we need to look at from this point is what are the other zeros? Well, we could try and factor this, but trust me, it's not going to work out very nicely. So what I'm going to do is set this equal to 0 and use the quadratic formula to find the remaining answers. So it's x equals negative b plus or minus the square root of b squared. Well, b squared is 36 minus 4ac. 4 times 1 times 13 is 52, all over 2a, or 2 times 1. So that's 6 plus or minus the square root of negative 16, all over 2. And realize that square root of negative 16, normally negatives bother us, but we're dealing with imaginaries, so we can go ahead and do that. Realize all this is 6 plus or minus 4i, all over 2. Realize the I is because of the negative, and the square root of 16 is 4. Now we look at this. 6, 4, and 2. 2 can go into each and every one of those, so this simplifies to 3 plus or minus 2i. Now remember that if we have one imaginary root, we need to have a second one. 3 plus 2i and 3 minus 2i. But we also know negative 3 was the third 0 that works. And the final example, example number 6, we need to find all the zeros and then write the polynomial as a product of linear factors, which basically means it'll be x plus 3, x minus 5 plus I, or something like that. It's just going to have a whole big long list here. So I start out with f of x equals x cubed plus 4x squared plus 8x plus 8. So I'm going to give myself a list of possible answers, rational answers. So it'll be 1, 2, 4, and 8, because I just take the factors of this, and down here will be 1. So it can be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. I'm not going to list those out. I'm just going to use this as my tool. So maybe I would try, maybe 1 will work. Maybe we can be so lucky. 1, 4, 8, 8. 1, 1, 5, 5. 13, 13, no such luck. So 1 doesn't work. And actually, if I would think about it, no positive is going to work, because if I put in a positive, this is just going to keep on bigger and bigger and bigger. So I need a negative. Let's try negative 1. See what we end up with. 1, negative 1. 3, negative 3. 5, negative 5, 3. Well, getting closer, but still not quite. Let's try negative 2. 1, 4, 8, 8. 1. Negative 2 is 2. Negative 4 makes 4. and negative 8 will be 0. Ah, there it is. And so I know negative 2 is one of my zeros. But even more importantly, I know x squared plus 2x plus 4 is what is left over. And so I can once again set this equal to 0 and solve using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 2 plus or minus the square root of negative 12 over 2. Okay, this will equal negative 2 plus or minus 2 square root of 3i all over 2. Now notice the 2's will basically cancel each other out, or basically we're left with negative 1 plus or minus root 3i. So negative 1 plus root 3i, negative 1 minus root 3i. So now the question becomes, we need to do one more thing. And that is, we need to write the polynomial as a product of linear factors. Well, we've done the hard part. We've got negative 2 is one of my zeros. So that's x plus 2. I know negative 1 plus root 3i is another one of my answers. So that'll be x plus 1 plus I root 3. And of course, the conjugate will be as well. Now be very careful. It's x minus this whole thing. That's why the minus 1 became a plus 1. Be very careful when you do this final step. But here is that final answer. We have a product of linear factors.